now. This is Neil Scott, and remind me your name. Dallin.
Dallin Sudbury.
Okay, I knew that. All right, so we are here at the University of Utah on acute, the 6th floor orthopedic floor, and these guys are going to show us a little bit about how they set up the 3D printing to create splints and adaptive equipment. So Neil, go ahead and show us what the first step in the process.
Okay, the first step in the process is just to get a 3D image of the person or the thing that you're working on.
Okay.
For me, I'm going to scan Dallin's arm.
Okay.
And this is an iPad, but it has attached to it an iSense scanner. It's a 3D scanner that you can attach to it. And it makes an image like this, and I'm just gonna hit record and get the image started. So now I'm gonna just start scanning, and it's gonna start building an image that I can work with eventually. And it'll just kind of mesh the pieces together for me like that.
All right. So then, oh, and that's automatically sending the information to the program that you have on this computer.
Well, it's sending it into a program that will mesh the image together and form what's called an STL, but it saves it as a file that we can work with.
Great. And what's this program called?
This is ScanEct. It's the program that came with this scanner.
Okay.
So this projects the image that we have. This over here is the route that the scanner took. From here is where we export it as the file we need it to be in to work in the other program.
Cool. So let's skip to the other program and show me, while he's skipping to that program, Neil, tell us a few of the things that you have designed and built with the scanner.
So one thing that we've made is just a custom AFO. We were able to scan someone's foot and then build the AFO around their foot. So instead of having just an off-the-shelf AFO that we're not sure will fit, we're a large, medium, small that we're guessing on. Same thing with a splint, just a custom splint with a thumb spica built in with it.
Very good.
And then also a custom C-collar, so we were able to scan someone's neck and then build a C-collar around them. Typically we're using an off-the-shelf C-collar that may not fit, you know, it fits most people's necks, but there are the occasions that we need something like this that fits more custom to them.
Okay. Tell about this one.
So we've also, we built a custom joystick based on a person's hand. So this fits someone's hand perfectly, along with this splint that fits. And anyway, we built them to fit together perfectly. We inlaid some spots for magnets, and now the person can wear the splint and then use the inlaid magnets to give them a little bit of grip strength. And this is a joystick for a wheelchair.
For a power wheelchair?
For a power wheelchair.
Fantastic. All right, so Dallin's got it loaded up now. The image that they scanned, it's in the program where they're going to build the splint or the piece of adaptive equipment.
Yeah, so this is the scan we have. From here we can take out some of the imperfections in the scan and clean it up and make it look, as long as the program doesn't freeze on that, look better. And then, so we smooth it up, make it look good, and then here we basically paint where we want the splint. So just because this is where we got, let's say we're making some sort of elbow splint right there on the side. And so we design our splint.
Okay.
And it's part of the scan.
So you just erased a little
So I
bit because
just
you're like,
erased
I
a
don't
little
want
bit.
that.
Because we don't want to deal with certain things in the video.
So as you're kind of clicking through and looking at that, oh man, sorry everyone about the recording. Neil, why don't you talk a little bit about some of the other things you've built as far as adaptive equipment? You've mentioned a lot of different kinds of splints. What else have you built?
We've built some adaptive equipment, socket, and then we have access to building on our 3D printer over here. Bottle openers, key holders, any of that adaptive equipment that you've kind of seen that you can fit in your hand. We're able to print that stuff off. And there's a lot of access to that on the computer or on
Very good.
over the
And
internet.
in fact, we will be sending the students some links for some open source websites that have 3D designs that can be downloaded and then sent to a 3D printer. So we'll get those to you.
Do you want me to talk about the cost?
Yes, that'd be great.
So a lot of this stuff I feel like seems overwhelming because it seems expensive, but actually this printer was a $5,000 printer. The iPad was something that we already had, and the scanner was $400, and the program that we're using to do the editing with came included with our printer, and then also we use a free program called Mesh Mixer. So this wasn't that expensive. I mean, in comparison to some of the other technologies that we use,
Right.
this was not an overwhelmingly expensive project for us to start working on.
Good. And talk a little bit then, you mentioned about the cost of splinting materials and things like that.
So splinting material for a sheet of it can be $100 for a sheet of splinting material, and then for a roll of 3D printing material that we use is, something like this is between $30 and $50 depending on the type of material you get, and then we can make multiple splints out of a kilo of splinting material that we bought. So it can be quite a bit cheaper to build the splint.
And then you also mentioned, like, when you're building something like a sockade. Well, a typical sockade, if you buy a bunch of sockades in bulk, they're going to be cheaper than building it this way. But if you need a custom type of sockade or other type of adaptive equipment, this can be a much less expensive way, particularly if you already have the scanner and the programs and the materials.
The width of the foot often makes a big difference on how the sockade works, or kind of the depth of the sockade and what. So we can change all of those things and make it exactly the way that we want it for each individual person.
Good. So let's talk a little bit about timeframes. How long does the whole process sort of take? So beginning with scanning the body part, how long does that usually take?
So scanning, you just saw how long it took to scan with everything set up. So if you get a good scan, it doesn't take too long, 10 to 15 minutes anywhere. Then designing it, depending on what you're designing and how good of a scan, there's certain cleanup that you have to do. Or if you get a good scan, it's less cleanup, so it goes faster. So
Okay.
the designing can be anywhere from 15 minutes for a simple brace like this to sometimes an hour, depending on the C-collar or something we're making.
Okay.
And then to print it off, this would take an hour to an hour and a half to print off.
Mm-hmm. And we talked a little bit before about the things that would impact the amount of time it takes for the printer to actually print it. You mentioned size, the size of the item, AFO versus a thumb spica. What are the other kind of factors that would impact how long it took to print?
Yeah, so we can make this as thick or as skinny as we want to, depending on the strength. And then in this other program, you can decide how much material you want to put in the middle of it. It's called infill. So you can either put 0% infill, which would be very weak, or you can put 100% infill, which would basically make it a solid object.
Okay.
So that is a...
Infill, spelled I-N-F-I-L-L. So size, shape, thickness.
I don't know if you can see.
Materials
I don't know
that
if you
you're
can see
using.
in here. So we have a solid layer on one side and a solid layer on the other, and then on the inside here is the infill, and you can see there's a certain amount. So this is a low amount of infill in here.
Okay.
We could make that even less, or we could make it almost completely solid based on the strength that we want out of the splint. But that will increase the time that it spends on the printer.
Okay.
It needs more layers down.
I wanted one more thing from this. You talked earlier about a gentleman who had multiple fractures in his hand, and you designed a splint for him. And there were some pretty specific things about that splint. Do you want to talk about that process?
Yeah, so the benefit of making that splint for that particular patient was his hand was so broken and open wounds everywhere and really painful, and he had 20 pins fixating his hand, his fingers, his back of his hand. And so he was positioned, I can't even get in the position, kind of like this. And so to even touch it was very painful for him. The benefit of doing it this way is we were able to get a scan of his hand without touching him, without causing any pain, print off the splint, and then put it on without any pain.
Nice.
So he was very happy that he didn't have to go through that painful process of having hot material put on wounds and having to try and work around his fingers and bumping them, and
Yeah.
that's the big benefit.
Fantastic. That is what we'll do for now, and you guys will send me those resources. Thank you.